Water. It's all around us. Makes up 70% of the Earth's surface and about 60% of your body. Let's start with the basics. Water is a colourless and transparent substance. When it is pure, it has no smell and no taste. If you've ever thought that one type of tap water tastes different to another, you're not wrong. Tap water in different areas may have slight impurities from various metal ions. Water is a liquid at room temperature. It freezes at 0 degrees and boils at 100 degrees at standard pressure. But have you ever wondered why the boiling point of water is higher than, for example, methanol? Well, you might know from this video that water is a polar molecule with slightly positively charged hydrogens and slightly negative oxygens. Imagine a bunch of water molecules in a beaker. They are in liquid form, so can move around each other, but the delta positive hydrogens from one molecule are weakly attracted to the delta negative oxygen of another. This is a type of intermolecular force, and it has a special name, hydrogen bonding. Because of this, the water molecules need quite a bit of energy to overcome the hydrogen bonds and escape from the beaker as a gas. Water is a very good polar solvent, so good it's often called the universal solvent. That's a bit of an exaggeration, but it's certainly true that many common chemical compounds will dissolve in water. Here's just a few: hydrochloric acid and many other acids, sodium hydroxide along with other bases, soluble salts such as table salt, sodium chloride, and sugars. Here's a challenge though. Can you think of a large and important type of compound that won't dissolve in water and instead floats on its surface? More importantly, can you think why they do this? Pause the video, think carefully, and resume when you've got the answer. Well, the answer is lipids, or in plain English, oils or fats. They don't dissolve in water because they're non-polar and therefore hydrophobic, meaning they don't like mixing with water. One of the most unusual qualities of water is that it can act as either an acid or a base. A water molecule can either accept a proton and become a hydronium ion with a +1 charge, or donate a proton and become a hydroxide ion with a -1 charge. This is one of the reasons why water is so useful in all sorts of organic chemistry reactions. We already use water for bathing, laundry, many industrial processes, and of course drinking. But perhaps even bigger things lie ahead. You see, many scientists all over the world are working on developing hydrogen as an alternative fuel source. We know it works for this purpose, but there are problems with storage, transportation, and refueling that are holding us back. Nonetheless, a lot of people believe that in the not too distant future, many of our machines and industries will be powered not by hydrocarbons, but hydrogen gas. And where are we going to find an almost limitless potential source of hydrogen to use for these purposes? You guessed it, the humble water molecule.